Okay, so you guys actually might want to move over here. You can see a little bit better because there's some stuff down on the bottom of the screen here. Okay. Well, in the lower left-hand corner, there's a couple of buttons that say Data View and Variable View. The Data View is where you put the data. Got that one? The Variable View is where you do things like give names to the variables and things like that. Okay? A lot of the stuff that we'll do is just going to be a pull-down menu kind of thing, mostly under Analyze. You can see a descriptive statistics there. Explore is the one we use the most. And then you can see compare means. One sample t-test, independent samples t-test, paired samples t-test, and one-way ANOVA. Those are the things that are on our upcoming exam. Okay? They're all right there in one spot. So what I'm going to do is just go to the data view down. I'm just going to make up a few numbers. Okay? Okay, so I've got 10 numbers now. The default is to call it VAR with a bunch of zeros, 1. I can either click on that or I can click on Variable View, and I'm just going to change that to X or score or whatever you want to call it. Now, when you name it here, you can't put any special characters or spaces. If you want to give it, whenever you want to have printout, if you wanted to say it, if you wanted to say score on exam 1, you can put anything you want in for the label. So even though it's called X here, in any printout that you get, it's going to call it score on exam 1. Now, from either one of these views, it doesn't make any difference which one you're on. You can just do Analyze, Descriptive, Explore. Analyze, Descriptive, Explore. And then you just, the arrow there just moves the variable over. Well, you could, but some of my data sets have a couple hundred variables in them. So the list is longer. And I only want to use 3 of them. I go find those variables and move them over. So the dependent list, we'll use the factor list in a minute. The dependent list just means whatever quantitative variable you're looking at. I'm going to get the mean score. Okay? And then under plots, I'm going to select that. The default is stem and leaf display. If you want to get a histogram, you have to check that yourself. Okay? And of course, that's under plots. There are some, I'm not going to do them, but there are some other things you can get for statistics, more percentiles and things there. You can change the level of confidence that you want right there if you want to. But I'm just going to leave that. So all I did was move the variable over, and I went under plots and selected histogram. Okay. Then I click OK. And it takes about the same time for 10 numbers as it does for a few thousand. So it gives you here score on exam 1. There's the mean, the 95% confidence interval, 5% trimmed mean, which we haven't covered. It just means take 5% of the data off before. The variance, the standard deviation, minimum, maximum. If I select percentiles, it would be giving the quartiles as well. Please, on things that you present to me, don't simply cut and paste that table in there, because you don't even know what that skewness or kurtosis. Only put things in your report that, or anything you present that you know. You need to know what they are. And they have to be related to the question you're answering. It's too easy with computers now to just say, here's 200 pages of output. That really doesn't do anybody any good. And if you did that at some place you worked, you're probably going to not work there very long. But the histogram came with that. There's the stem and leaf. And the box plots are automatic with that too. Okay, so that's how difficult it is to use this. Now, one of the things that I do with the box plots, for two reasons. One, I really dislike that color. I don't know why. I really don't normally go around disliking colors or anything. Maybe it's just because I've grown tired of it. Also, like if I'm printing something out, I like minimize the color because, I'm cheap. So if you double click on here, might have to do it a couple of times. Come on. I should be getting an editor window. There we go. Probably going to get about 10 of them now. So now I'm in the chart editor. Like if I want to change that color, I'm just going to double click in the middle of it. Okay? It says fill. I'm going to change that to white. If you change it to nothing, then you're going to get extra lines in the middle of it. So I'm going to change that to white, apply. Now that's white. I'm going to get rid of the background too, so I clicked over there. Fill. Now that's white. I don't have to print a bunch of gray or whatever that color is, yellow or brown or whatever. Also, if I go under, is it under options, I think? Under options, I can transpose the chart. And I like my box plots in this direction. That's it doesn't make any difference. That's just my particular, thought. And then you can just cut and paste that into your box plot or whatever. You can just cut and paste that into whatever you submit here or elsewhere. Now, if you can see down here, I've got two windows now on my taskbar. One of them is the output stuff that I'm looking at now. The other one is the data, both the data and variable views are in that one. So I'm going to go back to, and I can run more stuff from right here too, but I'm going to actually change the data up a little bit and do a couple of other things first. Okay? So I'm going to go back to the data now. Let's say that, first of all, let me add a couple of numbers here. Come on. Oh, there we go. What I'm going to do is I'm going to have a second variable now. And I'm going to say that these came from two different groups. Okay? And I'm just going to call them, and I suggest that you do as well, call them group 1. So I had 6 observations in group 1. It usually doesn't take this long for that to copy and stuff. That should have been a 1 up there. So now I have a second variable. This might be, I'm going to go to the variable view and call that class. So maybe the section that I'm in. And this is going to, as a qualitative variable. When you have a qualitative variable, I told you to put in group 1 and group 2. But when I have things print out, I don't want to just have 1 and 2 on there. So if you go over under values, just do this for qualitative variables, like the groups you're in or whatever, and click on that, and you'll see that that little blue box with the 3 dots in it comes up. Just click on that. And then I can say, when it said 1, put morning class. I'm going to add that. When it says 2, I want it to say afternoon class. Or I could have done online, classroom, whatever it was. Just add that in. Okay. So when you have a qualitative variable, go over, click under values, and tell it what you want the 1, 2, or 1, 2, and 3 to stand for. You can use other things besides 1, 2, and 3, but there really are some advantages to using 1s, 2s, and 3s. And I would just suggest that you do that routinely and then let the values thing take care of the rest. Okay, so now I can do analyze, descriptive, explore, and I can say, put it in a class in the factor list, and now I'm going to have 2 separate groups. And I can get the means and the standard deviations and the box plots, everything for both groups. I think, yeah, histogram's still selected. So the thing I did now is I added scores by group, and now you can see I have the means and standard deviations and everything for the morning class and for the afternoon class. Above that, it just said there were 6 in each class. That's really the only pertinent thing in that above there. And then I have both histograms, box plots, and there you can see I put in a high value so you can see it puts in the extreme value for you. And you can see, maybe not from back there, but up here you can see maybe that by that asterisk it has the number 11. All that means is that was the 11th value on the data set. It has no other meaning other than where was it in the data set. So you can go and look and see, well, maybe that was a data entry error. Maybe that should have been a 12 or a 2 or something. I just mistyped it or something. Or it could be a real value that you need to pay attention to. But that just tells you where to go look at it. So now for the t-test stuff, or at least a start on that. If I wanted to let's do a 1-sample t-test. Now I'm saying forget that there were groups 1 and 2, that I just have an X. So I select 1-sample t-test, and I just bring my score over there. And what I want to do is I want to compare this to 9, or whatever you want to. I can't remember why numbers are in there. I just want to test this again. So my HO is going to be mu equal to 9. And now I have, there's actually a table that's not too bad by itself right there, the n, the mean, the standard deviation, the standard error. But then I have the computed t-test, minus 0.942, the degrees of freedom. Then it has where it says significance two-tailed. Okay, that's the p-value. Why SPSS calls it significance, everybody else calls it p-value. But that is the p-value. And it's the two-tailed p-value. So if you're doing a two-tailed test, this is the p-value. If you're doing a one-tailed test, it's half of that. Okay? So you just have to remember that. If you're doing a one-tailed test, you've got to cut that in half before you make your comparison. And then here's the confidence interval. Okay? You may have noticed that when I did, there was a place for options. That's if you wanted to change to a 99 or a 90% confidence interval. You can do that there. I'll show you really quickly here. And so analyze, compare means, one sample t-test, options. So I could change that to 90 or 99 or whatever I want to change to it. That's really the only thing that you change there. So then, analyze, compare means independent samples t-test. Now I'm going to go back to I had 6 in each group. Okay. Independent samples t-test. Still testing on the score, but my grouping variable is class. Which class were they in? And it won't let you click OK yet. It's got the class, question. You have to define groups. And one of the good things, reasons, not the only, but certainly one reason to use 1s and 2s is I can just say group 1, I put 1s, and group 2, 2s. Okay? And then just continue. And now I can do that. And you can see it gives you the means and standard deviations in that top table. Then it gives you Levine's test for equality of variances. We're not going to use that in this class. And this class, we're using that when neither variance is twice the other. This is just a formal way of doing that. For here, I think it's just best that we stick with, if neither variance is twice the other, pool. If one of them is more than twice the other, don't pool. So our output really starts after that. So now we have the t-value, degrees of freedom, and you can see this one is for pooled and unpooled, which we've been getting from the unpooled, especially from our calculators. And then there's the two-tailed p-value, and there's the confidence interval. Okay. And you can see that they're not that much. They're a little bit different, but not that much different. And the p-values were 0.21 and 0.226. Not that much difference, but some. Okay, I'm going to go back to the data now, and to the data view. And what I'm going to do is add a group 3. By the way, notice that every row of this is one element. Okay. So that is what's on one row, is one person, what class they're in, and what their score was. Each column is a variable, the score they made or what class they're in. So just kind of fit this back with some of that definitional stuff. Each row is an element, got a variable in each one, and of course the values in each column are the values that the variables can attain. So now I've got 3 groups. If I do the analyze, descriptive, explore stuff, nothing's going to change there other than when I get to my histograms and box plots and everything, there's 3 of them now instead of just 2. So that was really no real difference in what you do there. Since there are 3 groups, though, when you compare means, that's the one-way ANOVA. 2 groups, independent samples, 3 or more groups, one-way ANOVA. And put the score over there, the factor is class, and it doesn't make you define them on the ANOVA. It didn't make any difference what you put there. Now, one thing I will also show you under post hoc, if you would, under that, select Tukey. You don't understand why now, but you will after the week. And then just click OK. And so when you do the ANOVA, when you're watching the lectures this week, it's going to have things like degrees of freedom. There's the 2 and 15. That's what you have to use in the F table. You'll see that when you look at the lectures. In fact, I'll give you that table in a minute here. Then there's the F test, there's the mean squares, and there's the p-value. There's actually ANOVA is 2 tests. You'll see one is just the overall ANOVA. That's just this top graph. And the second one is, the first hypothesis you're going to see is there's at least one difference between population means. Mu A not equal to mu B, mu A not equal to mu C, and or mu B not equal to mu C. HO is they're all equal. Any one of those 3 would reject HO. All this one says that there's at least one difference. On the bottom here, where it says multiple comparisons and when you get to the Tukey, this is where you say, okay, if I've rejected HO, which ones are different? Okay. So it'll be a little bit different than what I present in the lecture, but on this one, the way it's output here, you look at the confidence intervals. So for morning and afternoon, it has an interval that goes from -11 to +3. Is there a difference between morning and afternoon? No, it includes 0. So morning class and 3, I didn't go back and redefine what that is. It goes from -17 to -3. So what we're saying on this is the morning class is somewhere between about 17 and 3, less than whatever 3 is. So, and there's 6 things here, but there's really only 3 comparisons. 3 of them and then just the other way. So I usually just go the first 2 there and then skip to the afternoon minus 3 there. And it goes from minus 14 to 0.4, which includes 0. So it turns out that the only difference was between the morning and 3. At this point, don't worry too much if you didn't quite getting all of that, because you haven't seen the lectures on ANOVA yet. But we're just looking at, is there a difference between any of the means? If no, don't do this stuff. If yes, which ones are different? The only other thing I think I better show you on here is the matched pairs. It'll look a little bit different. Back to the data. And I'm going to call, let's see here. Maybe I'll just start over. What I'm going to have is it's never done this with the question marks before. I don't know why it's got to be something with this computer that's, we did put a new computer in a couple of weeks ago, so, upgrades go. But anyway, that would be like, say, the pretest. So now here's are some possible and I'm just going to call those pre-test and post-test. Now there's 2 ways you can go about this, and at least as far as just the straight test, match pairs t-test, I'm just going to do analyze, compare means, and pick the paired samples t-test. And what I want to do is I want to take that post-test, okay, post-test and move it over here, and then pre-test and move it over. So that's going to say post-test minus pre-test. I had 2 each one of those was just one element again, just the pre-test score and the post-test score. So this is just move it over the way you want to subtract. Then you have the means for it, but really it's the bottom thing that you want to look at. This mean where it says 1.33, we computed the differences and made x. That's the average of those x's. And then there's the standard deviation of the x's, the standard error, the confidence interval, which goes minus 1.6 to 4.3, which means there may have been no improvement because the interval includes 0. Then here's the t-test, the degrees of freedom, and then the p-value. Again, if it's a one-tailed test, you'd have to just take half of that. Okay, one more thing, and then that'll be the last thing I'll have to say about this. And that is, let's say you want to draw a histogram or a box plot of those improvements. Okay. You really don't need a box plot or histogram of the pre-test separate from the post-test. What you need is a histogram or a box plot of the differences themselves. So what you have to do, I'm going to go back to the wrong one here, so you can see what I'm doing is, what I'm going to do is I'm going to compute a third variable that's just the differences. Okay? So under transform compute variable, I'm just going to say improvement or x or whatever you want to call it is equal to post-test minus pretest, just like we would have done it on the board. And click OK. And now you will see, somehow I opened Opera up. I don't know what I did. But there it is. But you can see now that created another variable for me, improvements. And now if I want to get a box plot or anything like that, I just go Analyze, Descriptive, Explore, move improvements over, just like I did with the other ones. So all I've done here is just create a variable that's just the x's. By the way, I can do, when I did that matched pairs t-test, I went compare means, paired, and moved all that over. But now that I have this separate column, I can just do a one sample t-test and I'll get the same answer. If I put that improvement over here and compare to 0. Those are, on here, those are equivalent tests, either the pre, post, into the matched pairs, or get the differences ahead of time and just do a one test compared to 0. So you kind of have a choice then on what you want to do on the matched pairs, doing the t-test itself.